Welcome to Demystifying Math. In this lesson, we're going to be discussing the composition of functions. Let's start with these two functions. F of x is equal to 2x minus 3, and g of x is 3/2 x minus 1. We're going to find the composition of the two functions by putting the g function inside the f function. So where we have an x in the first function, we're going to put in 3/2 x minus 1. And now what we're going to do is distribute and simplify. So multiplying 2 times 3/2 x, we get 3x, and 2 times negative 1 is negative 2. And then we're going to subtract the 3. So now we're going to combine like terms. So f of g of x is equal to 3x minus 5. Next, we're going to work it in the opposite order. We're going to put the f function inside the g function. So in this case, we're going to take 2x minus 3 and put it in for x in the g function. So you have 3/2 times 2x minus 3 minus 1. And again, we're going to simplify. So distributing the 3/2 to the 2x, we get 3x. And distributing it to the negative 3, we get negative 9/2. And then we're going to subtract the 1. So we have 3x minus 11/2. Notice that composition is not the same. You have to watch out for the order. Here's our next two functions. We have f of x equal to 3x squared minus 4x, and g of x equal to x minus 3. We're going to compose the two functions together, and we're letting the g function be our inner function. So we're going to take x minus 3 and put it in for x here, and also x here. So it doesn't matter how many x's you have to replace all of them with the g function. So we have 3 times x minus 3 squared minus 4 times x minus 3. And we're going to simplify. So first we're going to FOIL out the x minus 3. So I have x squared minus 3x minus another 3x plus 9, or x squared minus 6x plus 9. I'm also distributing this negative 4 to the x and to the negative 3. So that gave me negative 4x plus 12. Now I'm going to distribute the 3 to the 3 terms in this trinomial. So you have 3x squared minus 18x plus 27 minus 4x plus 12. Then we're going to combine like terms, and we get 3x squared minus 22x plus 39. Now if we want to evaluate a composition of functions at a certain number, we can simply plug into the composite function that we found here. So we have 3 times 2 squared minus 22 times 2 plus 39, and that will evaluate the composition at 2. So in this case, I got 7. There is another way that we can do this. We can first evaluate the g function at 2. So plugging a 2 into my g function, I get 2 minus 3, which is going to give me negative 1. Now I'm going to take that result from the inner function and plug it into the outer function. So negative 1 goes into 3x squared minus 4x. And that gave me 7. Notice I got the two answers the same. It should always work out that way. So that's a good way for you to check your work. Here's two more functions. We have f of x equals 2 minus x over 3x, and g of x equals x plus 2. We want to look at the domain of these functions. In the first function, we can't divide by 0, so we're going to exclude 0 from our domain. For the second function, there are no restrictions on our domain, so we're just going to say that the domain is all reals. Now let's compose them. We want to find f of g of x. So again, we're going to take our g function and put it in for x here and here. So you have 2 minus x plus 2 and 3 times x plus 2, and we're going to simplify. So distributing the negative to the x and to the 2, we have 2 minus x minus 2, which is going to simplify to negative x over 3x plus 2. The domain of this function excludes negative 2. Again, we don't want to divide by 0. Okay, let's do our composition in the other direction. We're going to take the f function and put it in for x in the g function. So we have 2 minus x over 3x plus 2. We're going to combine these into one fraction. So I'm finding a common denominator. Remember, 2 is the same as 2 over 1. So I'm really just multiplying numerator and denominator by 3x. So I get 2 minus x plus 2 times 3x, which is 6x. And then simplifying the numerator, I have 2 plus 5x over 3x. For this domain, we can't divide by 0. So we're going to exclude that from the composite function. Now, keep in mind that if a number is not in the domain of the inner function, then it cannot be in the domain of the composite function. So always decide on your domain before you simplify. We can also evaluate composite functions by using their graphs. In this case, the red lines, represent f of x, and the blue represents g of x. We want to find f of g at 0. So what we're going to do is first evaluate the g function at 0. So going to the graph and looking to see where x is 0, we see that our output is negative 2. Now that was our inner function. So we're going to take that negative 2 and plug it into the f function. So we're going to the f function and looking at negative 2, and that would be around here. So that result is 4. So that tells us that the composite function evaluated at 0 should be 4. Let's try another one. Suppose we wanted to evaluate the function of the composite function at 3. We're going to go to the g function first and look for 3. And it shows that my output is 7. Now I have a 7 that I'm going to put into the outer function. So if I go to the f function and look for 7, I can see that my output is 7. So my result is 7 for the composite function. Okay, let's try some more. Suppose we wanted to find g of f of negative 3. The first thing that we're going to do is evaluate the f function at negative 3. So I'm going to go over here and I see negative 3, the output is 4. Now I'm going to take 4 and put it into the g function. Well, when I go to my g function, I see that there is no point at 4 marked on the line. So what I have to do is use the equation for the line to help me evaluate it. So the first thing I need to do is find the slope. So I'm using the 2 points that were given on that line, 3, 7, and 0, negative 2. And I'm finding my slope. So negative 2 minus 7 over 0 minus 3 gives me a slope of 3. In this case, the y-intercept was plotted. So my y-intercept, or my b value, in y equals mx plus b is negative 2. So that means I have 3 for my slope, which is m, x, plus b, which is negative 2. So 3x minus 2 is my g function. So how did that help us? Well, we were trying to evaluate the g function at 4. Now that I have my g function, I can just plug in 4 into my formula. So I have 3 times 4 minus 2, which is 10. So when I want to evaluate g of f of negative 3, I'm going to get 10. All right, thank you for tuning in to Demystifying Math.